Here we have a question involving dividing fractions. In order to divide two fractions, what you do is take the second one, find the reciprocal, and then you multiply. Reciprocal means you invert it. The denominator becomes the numerator becomes the denominator. Then you change it to multiplication. The first one just stays the same. Now there are some choices. For multiplying fractions, you could just multiply across the top. That would be a 12 times 5 is 60, an a squared times a b squared. Multiply across the bottom, a 5 times 6 is 30 times a times b. Or you could start reducing. For example, this says take 6, divide it into 12. Or another way to look at it is you can do the same thing to the top and the bottom of a fraction. So divide the bottom one by 6, divide the top one by 6. Well, if I divide this by 6, it's going to leave behind a 1. And if I divide this by 6, it's going to leave behind a 2. Same thing with the 5s. Divide by 5, it's going to leave behind a 1. Divide by 5, it's going to leave behind a 1. And you can do the same thing with the a's and the b's. This says I have b times b. So if you divide by b, and divide by b, it's actually going to cancel one of the b's here, leaving one of them behind. So we would have this is gone, and we'll leave behind a b. The exact same thing happens with the a's. So this a will cancel, leaving one a behind. Now, if you can see my writing in blue, what's left in the numerator is 2 times a times b. So 2 times a times b, and times 1, but then that doesn't change it. And the denominator just has 1 times 1. This says divide by 1. But if you have 2a and you divide by 1, that does not change it. That is still equal to 2ab. Okay, over here, we need to again use the order of operations, PEMDAS. So we need to do what's inside parentheses first. Well, inside the parentheses, there's nothing to do or reduce. That's just a 3/4. That's just a 7/9. Next, exponents. So we need to do the exponents. So this means the 3 has to be squared and the 4 has to be squared. So a 3 squared is 9, a 4 squared is 16. Don't change anything else yet. So 3 squared is 9, 4 squared is 16. After I did the squaring, I didn't need the parentheses anymore because the parentheses were to say both the 3 and the 4 get squared, which I already did right there. Over here, a 7 squared will be 49, a 9 squared is 81. All right, now dividing by a fraction means take the second one and invert it. So the 18 stays there, and then it's going to become multiplied by 16 over 9. The 49 stays there, then multiply, and it's 81 over 49. Now you can, as I did over here, reduce. So this means a 9 gets divided into an 18. There are times when people say, well, if this is a fraction, this needs to be a fraction. So I'm going to make it a fraction by saying it's over 1. But it's not really necessary to do that because this is just saying the 9, it won't divide into the 16, but the 9 will divide into the 18. So then I say divide by 9 leaves a 1, divide by 9 leaves a 2. The same thing over here, but it's going to cancel very nicely. Divide by 49 leaves a 1. Divide by 49 leaves a 1. So we still have the addition that's going to be done last. Then over here, I've got a 2 that's left over times a 16, and that's going to be 32. Over here, I have an 81 times a 1, so that's 81. And they are technically over 1, but as we saw over here, dividing by 1 doesn't change the numerator, so you might as well just write it in the simplified form. Well, let's see. An 8 plus a 3 is an 11. So that means 80 plus 30 is 110. Then as far as the ones, they've got 1 and 2 makes 3. Or you can do it the old-fashioned way, 81 and 32. Add the 1s is a 3. And then this is what I was talking about, the 8 plus 3 is 11. So it's going to be 113. For these next problems, we need, again, a common denominator in order to add or subtract two fractions. Well, with this, a 5, you're going to have a 5. And for 6, well, 6 is 2 times 3. But because neither a 2 or a 3 show up as a factor of 5, that means that this is saying you have to use the 2 and you have to use the 3. So that means that the least common denominator is going to be the 5 times the 6, or in other words, 30. So this problem, this fraction could be multiplied on the top and the bottom by 5 in order to produce a 30 in the denominator. This one could be multiplied by 6 in order to make the denominator 30. Notice that it doesn't matter if you multiply on the right or multiply on the left. When you're multiplying a string of numbers, the order doesn't matter. You'll get the same thing. 3 times 5 is 15. 5 times 3 is 15. So this first fraction to now over 30, then multiplying these two is going to be a 6 times 2 is 12, and the x just stays there. And then it's subtract, and this one is 3 times 5 is 15, and the x just stays there. All right, now that we've got the least common denominator of 30, we can combine these two. All you have to do is subtract 12x's minus 15x's. So that's really just saying how much is 12 minus 3? Saying the answer instead of the question. How much is 12 minus 15? Well, that's 3. Because the 15 is negative, it actually leaves behind negative 3. And because they are x's, you say it's x. Oh, here's one where we get to reduce. Because this number can be divided by 3, and this number can be divided by 3. So we have to go ahead and do that. Divide by 3 leaves a 1. Divide by 3 leaves a 10. So the final result is negative 1 times x. So that means negative x. You don't really have to put the 1 times. The denominator, 10. All right, one more problem here. So this is saying multiply, this is saying divide. Again, to divide fractions, you invert and multiply. So I'm going to leave the other ones alone for now. 20 over 72, 42 over 18, 16 over 20. Now technically what you could do is multiply 20 times 42 times 16, 72 times 18 times 20. So you'd have this big number in the numerator, this big number in the denominator. You would then have to reduce, which with those big numbers that would be extremely difficult. Instead you could start this reducing idea. Like you could divide this number by 20, it would leave a 1. divide this number by 20, and leave a 1. Let's see what else. I could divide this. This is going to be, let me see, 72 is 9 times 8 is 72. And then I could take that 8 and divide it into the 16. So cancel out this 8, divide it into the 16, it will go 2 times. What else? 42 is 7 times 6, so I could replace the 42 with 7 times 6, and then I could have the 6 divide into the 18. So you get rid of the 6, or divide out the 6, divide this by 6, and it leaves a 3. I think I better clean up my work before I finish. So I've got, in the numerator, there's a 1, there's a 7, and then there's a 2. For the denominator, there is a 9, there is a 3, and there is a 1. So what else could reduce? Let's see, a 7 is not going to divide into that. A 2 is not going to divide into either of those. The 1s don't really matter because it's just multiplying by 1 doesn't change it. So we've got the numerator is 14, and 9 times 3 is 27. It can't be reduced anymore.